Hi friends, this video we are going to see how to solve the PDE using the Fourier Transform. Before we start, we are going to give what is the derivative of the Fourier Transform. Let f be a continuously differentiable function with Fourier Transform f of omega. So you know the function f and their Fourier Transform is f of omega, and their derivative up to n minus 1 order derivative, both the n's are 0, then Fourier transform of f nth derivative of x equal to I omega whole power n times f of omega. So this is the result. Now I am going to use this result to solve this heat equation. Okay. How I can start first? First I want to check the boundary condition, because the x lies between whole real line, so it gives the idea I have to use only the Fourier transform, and this is the initial condition, because the time part is they given us 0. So this is the initial condition they given. I am going to first I want to apply the Fourier transform on both sides of the given differential equation. What will happen? Fourier transform of du by dt equal to Fourier transform of d square u by dx square. I will apply. So what is the definition of Fourier transform? Integral over minus infinity to plus infinite du by dt exponential of minus I omega x dx. My right hand side is integral over minus infinity to plus infinite d square u by dx square times exponential of minus I omega x dx. You look in my left hand side, the derivative depends on t, but the integration depends on x. So I can take derivative is outside. So this implies d by dt, because I am only take the derivative with respect to t. So u times exponential of minus I omega x dx. So here also derivative with respect to x and integration also with respect to x. I am going to use this result. Instead of fn, I have the n equal to 2. That is a special case. So this is equal to I omega whole square, the Fourier transform of f of u, that is integral over minus infinity to plus infinite u times exponential of minus I omega x dx. So now I take the Fourier transform of u equal to, now I take Fourier transform of f equal to capital U for notation confusion. Then I square is become minus omega square times capital U. My left hand side is d u by dt. So now this is the first order ODE. I can use various separation of variable method, or it's a linear equation only. So I can use the variation of parametric formula. So I will get u of omega comma t equal to some constant times exponential of minus omega square times u times t. Sorry, u will not come. Omega square times t. This is capital U, that is Fourier transform of u. But I require what is the k value also I want to determine. How I can determine? They give the initial condition. So find the Fourier transform of u of x comma 0. What is the answer will come? This is equal to Fourier transform of exponential of minus x square. So this answer is we already find what is the Fourier transform of Gaussian function exponential of minus a times x square, that is equal to square root of pi divided by a times exponential of minus omega square divided by 4a. This is we already find. So, in our case a equal to 1. So, we get square root of pi times exponential of minus omega square divided by 4. So, this is I taken because this is capital U of omega comma 0 is square root of pi times exponential of minus omega square divided by 4. So, from the equation A, I can taken as, so this is I take the equation number B. So, A t equal to 0 implies my left hand side is u of omega comma 0 equal to k times omega power 0 e power 0 is 1. So, this is I taken the equation number C. For comparing B and C, so k equal to square root of pi times exponential of minus omega square divided by 4. So, then my capital U of omega comma t equal to square root of pi times exponential of minus omega square divided by 4 times exponential of omega square times t minus omega square t. We already did it. Now, I will take combinedly, I will take square root of pi exponential of, I will take outside omega square 1 by 4 plus t. This is capital U of omega comma t, but I required the small u. So, what I will do? I will apply inverse Fourier transform on both sides. So, apply the inverse Fourier transform on both sides, then small u equal to, so what is the definition? 1 over 2 pi integral over minus infinity to plus infinite capital U of x comma omega comma t times exponential of I omega x integration with respect to d omega. This is the key. So, what is my u of omega comma t is in the given problem? Integral over minus infinity to plus infinite square root of pi exponential of minus omega square times 1 by 4 plus t times exponential of I omega x times d omega. Now, I am going to solve this problem. You take root pi is outside, so you will get 1 over 2 times square root of pi integral over minus infinity to plus infinite exponential of I omega x exponential of minus omega square 1 by 4 plus t times d omega. So, I will club it because exponential terms I will club it. So, 1 over 2 times square root of pi integral over minus infinity to plus infinite exponential of So I will take this guy as a some a, this guy as a ix as b. Okay, I will take for the notation coming because this is the constant only. So I will take 1 by 4 plus t equal to a, ix equal to b. So what will come? B times omega times exponential minus omega square times a d omega. I didn't change anything. I simply substitute 1 divided by 4 plus t as a, ix as b. So I will use the perfect square. Then I can easily able to find the integral value. So the further notation, so 1 over 2 times square root of pi integral over minus infinity to plus infinite. I want to make the perfect square. What I can take? So exponential of minus a I take outside, that is omega square minus b divided by a times omega d omega. So 1 over 2 times square root of pi integral over minus infinity to plus infinite exponential of minus a times omega minus b divided by 2a the whole square minus 1 minus it's become plus b square divided by 4a, because that a this a minus that will come times d omega. So this is independent of omega, so I can take the outside. So 1 over 2 times square root of pi exponential of b square divided by 4a times integral over minus infinity to plus infinite exponential of minus a times omega minus b over 2a the whole square times d omega. So when we are finding the Gaussian Fourier transform Gaussian function, at the time we already find what is the value for integral over minus infinity to plus infinite exponential of minus a times x square dx. This value we have already find. What is that value we find? Pi by square root of pi divided by a. We already find, because please, I already posted this video, please watch it. I will give the description also, the link. So now I will fact that this is I taken say some common quantity. So u equal to omega minus b divided by 2a. So du equal to d omega. Whenever u approaches the minus infinite, omega also approaches the minus infinite. Whenever u approach the plus infinite, omega also approach the plus infinite. So our integrand becomes one over 2 times square root of pi exponential of b square divided by 4a integral over minus infinity to plus infinite exponential of minus a times u square du. So the same way I will get the answer is 1 over 2 times square root of pi and exponential of b square divided by 4a times square root of pi divided by square root of a. This pi and this pi will cancel out. So what is the b? B I taken as ix, a equal to 1. So 1 over 2 exponential of minus, what is the b? b equal to ix, a equal to 1 by 4 plus t. So, what is the b square is? b square is minus x square divided by 4 times 1 by 4 plus t, 1 divided by 1 over 4 plus t. So, what is the answer is 1 divided by 2 times exponential of minus x square divided by 4t plus 1 times 1 over 4t plus 1 times 4. This 2 will cancel. 2. So, this is my u of x comma t equal to, sorry, here the square root will be there, I miss it. So, this is the square root will be there, this 2 and this 2, this is becomes square root of 4, the 2 will cancel. So, 1 over square root of 4t plus 1 times exponential of minus x square divided by 4t plus 1. This is the solution of the given differential equation. I hope in this video how to solve the PDE using the Fourier transform we explained. Thank you for watching this video.